Feel a little on the spot?
Little on the spot, yeah, I'm not gonna lie.
I can make it a little worse. I could just set up my tripod and just have the tripod so
Oh,
it's not
dear God, dear God.
All right, to get us back on track to what we're supposed to be doing, covering refrigerant would obviously be the first step when changing the hot gas valve. I would go ahead and just cut the power off to this thing so you don't have to worry about it, deal with it later. The plug is behind the machine. It's just a good idea to do that, get it done and out of the way. Right on. So now we're off. In my experience, trying to hook it up, the way it's set up like that is a super pain. So I like taking those black grommets out and then lifting up the hoses.
Okay.
They just have like little depressor things. That'll make your life easier. You don't have to worry about, you know, trying to stick your hoses through that little slot right there in the front.
Yeah.
That's the other thing we're gonna replace. This tab had broken off and we used a little screw to secure it temporarily until a new water tray came in.
I think I've done that once or twice.
What's that?
You use the screw.
Yeah, it's a good trick.
At like a boba tea place and then a cheesesteak place.
Oh, you know what?
Huh.
I totally forgot, but I think you should recover from here. So you recover liquid and not just gas. So I think the way it would work is you would take this guy off. Somebody's really strong. I think if you take that off, then you connect your hose to it, and then you use your refrigerant gauge, and you open this up, and that way you can pull liquid straight out of the receiver. You know what I mean?
Is that what you want me to do?
It's faster. Let's not do it. Let's just do it the old school way. After you get more comfortable with this, that's what you should have in your mind.
Okay.
Technically, that's the right way to do it. That's the fastest way to do it. What's going to end up happening is all your refrigerant is going to boil out of the receiver, and then you're going to recover it. It is what it is.
Yeah.
I mean, what do you want to do? You want to use that? But technically, that's the right way to do it. I would leave one connected there. Take your red hose, and instead of having it connected there, have it connected to this side. Technically, the receiver is the high side of the system. You know what I mean?
Okay.
So all of the compressor compresses everything through the condenser and then into the receiver.
So what, I just need some channel locks?
You would just need your refrigerant tool.
Okay.
Your little refrigerant wrench.
Okay.
To open that up right now, you just need an adjustable.
Big, small?
It doesn't matter.
Okay.
I think they'll both work. Maybe that's big enough. So you take the black cap
Like here?
off. Yeah. And then the other cap should come off. There shouldn't be any pressure behind that cap. Just make sure the copper line doesn't bend.
That's probably where I need another wrench.
And you get another wrench.
It's kind of like a Hashizaki.
Yeah, it's exactly like that. I think if you screw it all the way in, you close it off. If you put it halfway, is where you end up having pressure at that cap, and you can experiment with it once you get your hose connected. You're gonna want to make sure you set up the rest of your hoses to where you can bleed off, you know, or bleed all the regular air out of the line, so it's just refrigerant inside.
Okay.
Is this closed off? There we go. Yeah, that's closed off. You're just gonna wait till you see pressure?
What's up?
You're just gonna wait till you see pressure on this? That way you would know when that was open? Or are you not ready to do that?
Well, you said to have everything connected, right?
Yeah, I mean, you're at a good step right now.
Okay.
I'm just trying to see what your next step is, or if you want me to tell you what the next step is.
Should probably have everything connected, right?
Yep,
Yeah.
you're doing good. You're on the right track. Hey, Patrick, maybe right here?
They got a lot of
I don't know if that goes anything. See if you plug it in, if the other end lights up. I don't know if that's energized or not. Yep, there it is.
One of the handles was like a regular handle, and then the liquid was a blue. You know what I mean?
Yeah, something wasn't right is what you're saying?
I'm gonna need an extra hose, aren't I?
Essentially what we're doing is we're just getting everything set up for right now. You have one hose on the liquid line coming off of the receiver, and you have your low side hose connected to the low side on the front of the machine. You're going to bleed off the air
Right.
to that point, and then
Okay.
you're connected to the in, and then your additional hose is going to come out of the out and then go into your
That's right. So
recovery tank.
So I need to grab an extra hose.
Yeah, I've gotten into the habit of keeping an extra refrigerant hose with my recovery tank at all times because it just makes more sense.
Oh, that makes sense.
I usually keep it with the machine.
Okay.
So I'll just kind of roll it up into a little loop and shove it right inside there.
Okay.
And then that's where that one hose in my van has lived there for the last 3 years, however long it took me to, wise up to the fact that, I kept on having to go back to the van every single time I recovered and dig out a hose from someplace. And then I just got smart and
Yeah.
that's its home now.
And we are going liquid, right?
I would go vapor.
Okay.
Just because when you push everything into here, instead of having a solid column of liquid, in your hose, it'll just be vapor.
Okay.
And I usually like putting this lower than the machine so that the liquid will actually fall into your tank and not just hang out inside the hose. And it kind of sounds stupid, but if you this thing will end up being all liquid if you connect it to the red one.
Yeah.
Wait. Yeah, vapor. If you connect it to the red one, this whole hose will just be full up with liquid, and then when you go to disconnect it, it'll spray shit all over the place.
Are these hoses just too long? I mean,
yeah, you're gonna need to get 3-foot hoses instead of whatever these are, 5-foot hoses. Eventually,
okay,
pretty sure they're 5-foot.
probably.
So before you open up that side, I would
Yeah.
leave that end loose, right? Yeah, that connector, so that you have a place to bleed off from.
Okay.
And then I would probably bleed out this line first,
Okay.
just to here. So I would have, have that open, and then so I would open this, and I would open this one,
Okay.
and then so there's a loose point right here. You gotta tighten that one.
Okay.
And then you should get refrigerant flow from that point. So it should bleed through this entire thing. I don't see why it's not. Is that closed?
It's open.
Is there something in here that has a Schrader or something? So, here, let me see something. Maybe I'm wrong. Let's see. So we got flow to here. We don't have flow coming out of here. Why don't we have flow coming out of here?
We haven't opened that side yet.
Well, so we have flow there. What's going on with the end of that hose? Is that like a?
It's an anti-blowback fitting.
So nothing's gonna come out of there?
Probably not.
And watch your eyes. But let's see. Oh yeah. Do you have another hose that doesn't have that connector on the end?
I think so. Yeah.
Just like a regular Schrader connector. So what we're having an issue with is this fitting doesn't just allow refrigerant to flow through. It's got a stopper in it for some reason. I'm not sure how this works, but it says it's anti-blowback fitting, which, like I said, I don't know what that means unless these things just need to get swapped sides. I think that's what it is. This one might be able to work if we just trade sides. Let's see. Because I think this one, it allows refrigerant to flow in this way, but not out that direction.
Okay. So
maybe if you just swap these, put this on here, and see what happens if I open this. There we go. So that is blowing the air out of this line, your recovery hose, your tank, and then this line. So when you connect it to there, you should be good to go. But actually what we're gonna do is we're gonna cut this guy off, and then we're gonna do the same thing to blow the air out of this line.
Okay.
But you can loosely connect it there, just so there's enough for the pressure to escape, so you don't want to tighten it down. And then come over and use your refrigerant tool, your ratchet, to do that part.
Okay.
So essentially you're just gonna, I think it's halfway, and like I said, hold on to that thing so the copper doesn't get bent. And you're trying to screw it in, so I'm not sure if that's righty-tighty or lefty-loosey. I think if you go up, it should ratchet it in. Like, you know what I mean?
To clockwork.
Like if you go clockwise, it might turn it in. There we go. All right, so I can hear pressure now.
Okay. So you said
It's not a lot. Let it run through, because you're going to need to get the air out of this line and have it flow and come out this end.
Okay.
And that's liquid refrigerant, so it should
start spitting liquid
a little bit. There we go. I'm gonna tighten that down, and now you're good to go. You can open that to probably the halfway point, because I think if you turn it all the way, it'll stop the flow. So like you'll isolate the receiver.
So you say halfway, like how much?
I don't know. Go all the way and then go back half. That way you can get a feel for it. Okay. And like I said, I might even be wrong about that shutting off access to the receiver. So you got to a stopping point, and now you're gonna go back.
Maybe half.
Well, I mean, if refrigerant comes out of there, you're probably close. You could count how many ratchets it is and then split the number in half if you really wanted to get technical. But so this is open. That's open. That one's not open down there, the valve. And then as soon as you open that up, refrigerant should start flowing into your tank.
Okay. Do I need to turn it on first and then open it, or?
I would open it up so that
it starts.
It doesn't. Yeah. So that your thing doesn't start up under pressure.
Okay.
Try to get it equalized. It might be the wrong way to do it, but we'll find out.
All the way?
Yeah.
Okay.
All the way, and all the way for at least your liquid, and then your recovery hose. Have the recovery hose one, the yellow one, open all the way. Doesn't seem like there's any flow going into there. Are you sure that thing's open? You might just be able to power on your recovery machine and see what happens. Kind of a hard start, but it's working. You can see the refrigerant bouncing around.
You see the numbers dropping a little bit too.
You'll be able to feel it coming through here as well. Eventually this thing will start frosting up, because there'll be a little bit of refrigerant at the bottom that's boiling off. We just let that run and then check on it when it's done. Your pressures are down pretty low. I would go ahead and cut it off. You have the backflow preventer thing, so.
Cut everything?
Yeah, turn it all off. This guy over here can stay exactly the way it is. Not anything special. I would use your Schrader remover. Take out your Schraders. You have a solenoid magnet?
I don't think I do.
I
have a magnet.
It's like circular, looks like a solenoid. I'm gonna run out to my van and see what I can. Well, I know I have one, but I only have one.
Can I leave this one, or should I take it out?
I would just leave it the way it is, honestly. We need to flow nitrogen, but here's what I would focus on right now is I would take out the stuff that I showed you, like unplug the solenoid.
Yeah.
Undo your high pressure wires, cut that zip tie, use your Schrader, take those Schraders out, because we want to make sure there's no pressure in the system before we start cutting or welding, because if you hit a pressurized refrigerant line with a torch, it'll blow, you know what I mean?
Yeah.
It'll be like Shamu's blowhole.
Definitely no pressure.
You have one of these?
What's that?
Solenoid magnet.
No.
Take the little solenoid out the top, and this is how you can manually open it. It's just a magnet.
Yeah.
The solenoids are just magnets. Like,
yeah.
When the electricity goes through it, they turn into magnets. This is just like a permanent magnet. I don't know if that's the right word for it, but.
Where would you find something like that?
Amazon. CPS.
What am I thinking?
Amazon. For the video, I'll.
Brought to you by Amazon.
No. I'll drop a link. Maybe if somebody buys one, I'll get some money.
I'm sure, like True Tech or something.
Yeah, I mean, I don't have an affiliate link for True Tech, but Amazon's pretty simple. They give me like 2 cents every time someone buys a bottle of cleaner.
Really?
Yeah, something like that. It's cold as shit out here, man. What the hell? So what is it that you're doing over there?
Removing the wires from the high pressure cutout switch.
You're trying to disconnect stuff from that line, because instead of replacing the hot gas valve buried way down deep inside here, we're just going to remove it, because we're well aware of the fact that welding copper to stainless steel in enclosed places is pretty hard to do, right?
That's what I asked Scott when we were at that restaurant on Thursday. I asked him.
You guys were at a restaurant on Thursday. Why wasn't I invited? You guys having dinner without me?
Well, we were actually doing work there too.
Oh, okay.
And I asked him because I knew we were coming out here. I'd said, couldn't you, in theory, just take this assembly out and weld it away from the machine and then put it back in? He said, yes, that is actually the way he does it.
Yeah.
So
Speaking of him doing it that way, I thought that he frowned upon it. I thought that he was anti, removing the assembly. And I told him, I was like, I'm gonna do it the loser Jeff way. He's like, what do you mean? I do it that way. And I was like, oh, what? Really?
Really?
Awesome.
Because he called it the Scott method.
Oh yeah, well that's what he said. He said, no. Frank always calls it the Scott method.
Oh yeah. Frank called it the Scott method.
And I was like, oh, I thought you and Frank were in the same boat, like hating on anyone that did it call it the sissy lala way or whatever you want to say about it. So that gives you a shitload of access.
It does.
You can.
It is a nice bit of access.
Yeah,
The whole time we were on our way in, I just kept thinking of FOD.
doing a FOD walk.
Yeah, and I should remove this
What
sensor.
we're gonna do
right?
is we're gonna cut the copper
Ooh.
line right here
Ooh.
instead of unwelding and rewelding, because we've had bad experiences with this T burning out, and then trying to redo this whole section is a major pain. Not a movie reference, but if we cut it and then swedge one side, and then we can just marry them back together and go from there. Like I said, before you cut anything, you make sure that you don't have any pressure in your system. And you have this open.
All that's
You have
open.
the straighters off, but you
All the
need to make
straighters
sure
are
you exercise that solenoid in case there's. I don't think there's any in there, but it's better to be safe than sorry. I'm over here shaking because it's so freaking cold.
How do you take the cover off?
You're talking about the solenoid off of the valve?
Yeah.
Oh, that's fun.
Is there a
I mean, you
pin
can
or
leave it on
something?
there for now. Just unplug it.
Okay.
I'll show you how to do it when you bring it out.
Okay. I'm not gonna melt it, am I?
You're talking about taking that part off with the two spades on it, taking that out?
Well, like this.
Oh,
cover.
you need to exercise it, right? To make sure that there's not any, what do you call it? Exercise it so there's not any pressure in it. So use a flathead screwdriver and you just get between the valve and the solenoid, and then just turn the flathead and it should just pop right out of there. So on the bottom.
On the bottom.
So I don't know if you can see it from.
It's kind of like down here.
It's super unfortunate. Like we all know that Manitowoc loves technicians, but the hot gas valve is
Like down here.
higher. Yeah, right between there. I don't know if you can see what he's doing, but shove it right in there, and then now just twist your screwdriver. Once you shove it in there, now twist. And it should pop out. Try twisting the screwdriver the other way. Oh, you're not in there. There, now twist. There we go. Let me get you this guy. I'm gonna say affiliate link, Amazon. Cost $20, I think. Just be ready to take it off in case you start getting refrigerant blowing out of your. You shouldn't, but it's always be better safe than sorry. There you go. That click is the valve opening. So you're good. Now you just use your cutter and just cut the whole assembly out. It's the easiest way to do it. You decide where you're gonna cut?
So not sure if this is cracking right here or not. So I might cut right here. Like, what do you think of that? Think that's a little crack?
You say crack?
Yeah.
That's probably a scratch mark from where the thermistor was clamped.
Okay.
Yeah, that's fine. Or if you really want to, just unweld that, and then if it's a pain in the ass to put back together, then we just cut that whole section out and put a new piece in.
Okay.
So that's the previous guy's work. Those are usually easier to unweld and reweld than these T's. We just want to avoid the T's because the T's are made out of like thinner, worse quality copper. And they have a tendency to like blow holes in them. So you do you. I'm here to observe and report like Anna Faris and who's that guy from Superbad? Seth Rogen.
Yeah.
So yeah, it's going to be kind of tricky, but I think we should be able to get it out. Nice. Look at that. You got the whole assembly out of there. All right. Now we come out here and we try to find a way to set this up. And then the most important thing, you're going to want to flow some nitrogen through there. It's going to be a pain to do.
Yeah.
But I think if you connect one of your refrigerant hoses to this Schrader right here, it'll be better than nothing.
Okay.
And the reason why you put nitrogen in the system is?
Put nitrogen in the system while you're welding?
Yeah. Because nitrogen is an inert gas, and it reduces the oxidation buildup inside of the copper line.
Okay.
So if you ever weld and you see like the black soot type stuff on it,
So it just keeps debris out?
yeah, it keeps it clean.
Okay.
And when you cut this, just out of curiosity, did you consider swedging it and reconnecting it? How much room you gave yourself?
Well, I did.
Is it just not a good spot?
Well, it really wasn't, because I suppose I could have pulled it out more.
I think it'll work because you probably swedge this end and shove that other side in there.
Yeah.
So it's
Same
probably
with
not
this.
a big deal.
Okay.
So this is the way I do it, just so you're aware.
Okay.
Since you're going to be flowing with nitrogen, I try to find a way to set this up just like this. See how it's standing up on its edge?
Got a pair of vice grips somewhere.
I thought that was kind of cool that it balanced just like that.
Yeah.
So what you would end up doing, if I were in your shoes, I would unsweat this guy right here.
Uh-huh.
And then I would get my new valve and I would plug it directly on top of there and then complete that weld.
Okay.
And welding copper to stainless steel is tricky. And the main thing is don't put a lot of heat on the stainless steel. Otherwise, you'll blow a hole in it. And then the ice machine is down until we can get a new valve.
Okay.
But you have to come up with your own way. My way is not going to work for you. You have to do it your own way. Do you have rags? I'll go get them wet for you. And you're probably going to want to connect your nitrogen there.
For this weld?
Yeah, because you actually have a Schrader.
Okay.
And that'll, some will come out the top, some will come out here. Do you need me to go grab rags?
All right.
Or I'll go grab some.
They're just in that black tub right inside.
The microfiber or the regular ones? Ooh. How many do you think you need? 2, 5, 12?
Yeah, it's 4 or 5. Because I'll need them in
45?
a few places, right? 4 or 5.
Yeah, I use them too to help balance everything. Now my hands are freezing and water. You can probably even throw your recovery on the ground, give yourself more room. God almighty.
Bring this closer. Yeah, I'm out. The settling. Yeah.
Shit, I didn't grab you. You said you don't have spare bottles?
No.
Next time you go to RSD,
I need
get your refill and then tell them for a new bottle.
new bottle.
Yeah, and
Yeah.
if you want to run that by whoever, you can, but I'm telling you, you need it. There's one at the shop.
Okay.
You're gonna go back to the shop after this, take that one, tell Scott, like, hey, I don't have replacement bottles, and he'll let you have them, I'm sure.
Okay. Thank you, sir. Yeah, that's definitely out. How many extra bottles do you carry? Just one extra?
Yeah, I have the one that I use. That's part of my kit, and then I just have an extra bottle on my refrigerant rack. Seems like the best way to do it. I used to only carry one, and then I ran out once in the middle of a job.
Jeez.
That wasn't fun.
It wouldn't be fun.
I have a lot of experience working with the torches.
No.
Neither do I. I think you want to regulate it at the valves over here, not there. So you should have, cut your flame off. Why does that say 0? Is this open?
Yeah.
No, now it's open.
I had it open, I thought. So I was moving it. I thought.
So just open up your valve for the oxygen.
Okay.
So that's way too high. You're at 40 psi on your oxygen. You should be down. And you can look at the, just Google it. Or you can stop with that now.
Okay.
And now do the same thing for the acetylene. You're not that bad on acetylene. You're at 6. All right, go ahead.
Okay.
Now try it. I'm not sure exactly what it's supposed to be. I don't adjust mine hardly freaking ever. But I think it's like, if you start off with like 10 and 10, you're probably in the ballpark. That's whatever you're doing is way too high. Is that oxygen?
On fuel, and then...
No, yeah, just do the fuel first. Your pressure is super high, man.
Cut it out or try it.
Let me see. Turn it off.
Jesus.
All right, let's see. I also probably have a different tip than I am used to. So, yeah, that might be fine. Are you flowing nitrogen?
Not yet. Oh.
No.
Okay. Low nitrogen.
Too much. Turn your pressure down. It should be this. So you shouldn't have to regulate it through this. That should just be open. So that's probably plenty. Like if you can hear it, probably too much, but I mean I know that there's flow coming out of there.
Okay.
I can hear it just barely.
All right.
So what you're gonna want to do is, I'll help you out. I'll hold this.
Okay.
But I would use your gloves and I would hold onto this and I would just unweld it directly from right here. And you're gonna want to warm this area up to where the solder just starts melting, and it'll probably pop right out of there. If not, you can brush your flame right over the stainless just to heat it up a little bit.
Mm-hmm.
But the stainless will start glowing red, and immediately it'll blow a hole in it. So don't overdo it.
Yeah.
Let me grab my gloves.
Jesus Christ.
Working with your torch,
Yeah.
and stuff like that, that's just something you're gonna have to figure out. And the only way you're gonna get you better at it is practice. All right, I'm gonna help you out.
Like that.
You know, you don't even really need me to hold it. You can use this if you really wanted to. So now that's not going to go anywhere. Just have your recovery tank hanging on the back of it.
Do you think that's okay?
It's probably not going to be hot enough. I would add more oxygen to it. That's probably perfect.
Yeah.
Yeah, maybe even, yeah, that's probably fine.
Okay.
There's only one way to find out. I would take this part off first, unweld right here,
Mm-hmm.
and then you can set this off to the side. Just remember that how this is set up, because once you remove this, you're gonna put the new one on in its place, and it's gonna go directly on there and then directly onto there.
So I should take this one off first,
I
or
would
this
take
one
this
off?
one off first, because this is all being held up, and that's where you have your nitrogen flow in.
Okay.
So I would take this off first, and then take this one off second.
Okay.
You could probably even just hold it right here. It's not like it's gonna burn you.
There.
And try not to burn your recovery tank.
Yeah.
Maybe come around this side.
Yeah.
Do it like that. Okay. I'll show you.
Yeah. There you go.
How's that? I'm gonna set this down right here.
Okay.
It's hot as shit. And now you're gonna do the same thing on this one, but now you can use your pliers and just kind of grip it.
Yep.
And if you want, I can just move this out of the way. Give you a little bit more access. Your flame should be more on the copper than on the stainless steel. And as soon as you start seeing it get red, that's when you know that you're, getting ready to blow a hole. So you got to take off the heat. Kind of move your flame around. There it is. All right, so keep going with the heat. All right.
Yep.
Now you can cut that off. All right. Good stuff. Good stuff. All right. So now what we're going to do is we're going to put this one in there. So the thing about this now, do you have, so this goes like that, right? Do you remember? Was it like that?
Yeah, because that's the fan cycle, so, or excuse me, the high pressure, so it would be facing up like that.
Yeah. So your new one's gonna go on like this.
Yeah.
Still flowing nitrogen, which is good. You're gonna want to cover this body in
Wet rag?
wet rag. Do you have wet rag?
I don't.
So
I have
add
a
that
wet
to
rag.
your RSD list.
Yeah.
I mean, I guess technically you could wipe it in the literal wet rag, but then you're also gonna have a whole freaking rag worth of shit on here. If you get lucky, you can kind of like force this on here.
And then just kind of melt the solder.
Yeah.
And it kind of falls down. Well, not falls, but I mean, just kind of.
The way I like doing it is I like having it like this so that my weld goes down.
Mm-hmm.
And then I guess you could wrap it in a literal wet rag. And then you can weld it just like that. Just You're not always going to have somebody here to hold it for you.
Yeah.
So if you have your weld and you have your, what do you call it? You have your rod, have your torch and have your rod, heat this up to where your solder will go on there. And then you're going to take your puddle of solder and you're going to move your puddle of solder down towards the stainless steel.
Okay.
And then the capillary effect will just take over and the solder will get sucked into the space between the stainless steel and the copper. All right, we're gonna just get after it. If you want to throw that recovery tank on the ground, give yourself more room. Or I can try to hold this up here. You can use this as a tester too.
What's up?
Like have this on there.
Oh, if it's hot enough?
Yeah, once it starts to melt, you'll know. See, it slid in there the rest of the way, so that's a good thing.
Yeah.
All the copper on the all the solder melted, and the copper slid into the valve the rest of the way. You want to try to be fast with it. The more heat that goes on the valve, the more likely it is to break.
Think that's good?
Now, fill that whole gap in. Yeah, I think they call it the shoulder or whatever. Just fill it all in with solder. What do you think? You think you're good? Does it look all filled in? Yeah? All right, call it good.
I guess we'll find out if it leaks, right?
Yeah. I mean, it just sucks because it'll be all the way inside the machine when it decides to start leaking.
Yeah. Well,
I mean, honestly, bro, you're probably good. I was burning myself. All right. So now goes the fun part, which is doing it the other way. Do that like that. I'm gonna use this again, because I don't want to have to hold it no more. And then this one has a little bit more of a shoulder on it than the other one, but
yeah.
if you can kind of get it to go in there.
Yeah.
And the only thing that sucks is it's going to want to fall out. So you can get creative with, how you set this up. If you imagine that you're by yourself and you're like, okay, well, how am I going to weld this? I mean, you could technically weld it like that. You could try to put this upside down and weld like that.
I think
You know what I mean? Like,
I may rig up a vise of somehow. I mean, that's for the future, but I think I can do it somehow.
Yeah, I think a setup like this is probably good.
Yeah,
It's not going to fall out, but you need to set it up in a way to where you can take this and wrap this guy really well, because you don't want your valve to get overheated.
Yeah.
So if you can find a way to get it to stay just like this, you're flowing nitrogen. Technically, you want to put that solenoid on. What happened to that yellow thing?
Yellow thing.
The magnet.
Oh,
right here. So
I mean, in theory,
you have nitrogen on this side of the valve, but you don't have any nitrogen on this side of the valve.
Yeah.
So technically, you would want this on here.
Okay.
And then you'd want to wrap this up.
In theory, if we plugged each of the holes and we're running nitrogen through it, couldn't we bubble around all the joints just to be sure that it's good before we throw it in?
You could, but what are you going to plug up on both ends that are going to give you, 200 psi?
Well, do you need 200 psi?
If you're not going to pressurize it all the way up to 200, I don't really see the point in pressurizing it, because you want to match the system's pressure at least.
Yeah.
410 is pretty high pressured stuff, so
yeah, that's fair.
I think that's not going to go anywhere. This might turn. If it does, we'll deal with it at that point in time. But the way you did this side was more or less perfect.
Okay.
Just do the same thing and see how it goes.
What the hell? It's not that I doubt it. It's very out of practice,
Yeah, 100%. You see? Just keep holding it.
Just kind of don't really want to fuck up that valve. I know it's getting hot, so.
Yeah. Hopefully that's good. Use one of those other wet rags and just you And then we'll inspect it. It's probably good. Let's see what's going on. So you routed this thing all the way back in here, right?
Mm-hmm.
You're gonna make that weld right there. And then you're gonna come around this side. And unfortunately, you're gonna make these two welds here, and that's kind of terrible, but such is life. C'est la vie, homie. C'est la vie. I'm not even gonna, you know, record the whole thing. I'll just check out the welds when you're done. All right, so what are we doing now?
Pressurizing 150.
All right, you can probably stop at 150 and just kind of get a sense. Check your welds, get some soap bubbles. Yeah, 150 sounds good for now to just kind of get a sense for where it's at.
Okay.
That connection at the hot gas valve is the most important. Yeah, imagine trying to weld that down inside there. No, thank you. So we are all done pressurizing the system, checking our welds for leaks. Now what we're doing is relieving the pressure, getting all the nitrogen out of the system, connect the vacuum pump, micron gauge, start running the vacuum on this thing all the way down to 500 as just a baseline. Be careful on this cord. This cord has seen better days.
Yeah.
I'm actually going to take that apart and redo it once my new one's all set up and ready to go. This thing's still a champ. It just it's kind of ancient.
Gotcha. Does that all look right to you?
Yeah.
All the way open, all the way open.
Starting to read.
7,000, 6,000, 60,
Yep.
50,000.
This all looks really good. Now we just get to tell the camera that we made a little boo-boo. Started pulling the vacuum before changing the filter dryer, which is super important.
We got excited and got ahead of ourselves.
Yeah, them YouTube warriors are gonna slay our ass.
Well, we just skipped to the part where we do it, you know?
Little cut and paste action.
Mm-hmm.
It is cold as shit.
Yeah.
It's all good. We just get back there, change it out, and then go back to
What we were doing.
what we were doing exactly. So we went back, cut off our vacuum, replaced with this guy. Wow. Brand new filter dryer. That's still pretty warm. That's not that bad. We'll go ahead and connect this, and then you can rerun the vacuum. All right, ready? It's on there?
It's on.
All right, so I'm gonna go ahead and do it, but remember, I'm gonna close this first.
Okay.
Cut that off.
Okay.
We're gonna close off the suction side, so we're gonna be dumping refrigerant straight into the receiver.
Okay.
Closed. That's closed still. So when you're ready and it's all zeros, right?
Yep.
All right, ready?
Yep.
All right, we're dumping.
Right.
It should be liquid going into the straight into the receiver. And it's gonna end up, dying on you, or not dying, but slowing down.
Mm-hmm.
Whatever the actual measurement is. This machine takes 112 ounces, which is 7 pounds exactly. 112 divided by 7 is 7 pounds. No, 112 divided by 16 is 7 pounds.
Slowing down though. It's at 210, 212, 213.
All right, so the easiest way to do this is just to plug it in and suck the rest of it in.
Okay.
Unfortunately, you're probably not going to be able to get much more into the liquid side because that's going to turn into your high side. What you're going to want to do is you're going to want to close this guy off, or whatever it is, open it all the way back up with your tool. And I just turned the machine on, so if it starts running for some reason, you'll know why.
Okay. So close it.
Yeah, so it actually is, it's all the way out towards you.
Okay.
Is the way you want to go.
Counterclockwise?
Yes. Counterclockwise is out.
Okay.
And so that cuts off pressure to the Schrader.
Okay.
And then leaves the refrigerant line open. You can just leave it connected for now. We'll deal with the rest of it later. But we're gonna go ahead and just turn it on.
Okay.
And we need to be in a position where we can meter it in, and you're gonna be looking at your sight glass, trying not to, so like when this thing kicks on,
Mm-hmm.
you can close this guy off. You can let it suck out the refrigerant that's in here, but you're gonna just crack this open, and you're gonna wanna, watch that. Like once that starts filling up with liquid, you're gonna, excuse me, wrong one. It's this one. You're gonna let this one go in. That's gonna fill up with liquid, and you're gonna close it, and then that's gonna boil off. And that's just to ensure that, your liquid boils off in here, not liquid ends up going into the compressor.
Okay.
So it's starting up right now. So that's closed. We're gonna open that. That's already open, and it's already kind of boiling off that refrigerant. There's just a little bit of bubbles now, and that's pulling down. And you're just gonna try to keep it
Just a little bubbly.
just a little bit at a time. You can just kind of base it off pressure, plus keep an eye on that. It's gonna want to end up sucking all the way down into, your zero range. You don't want that to happen. And this thing's gonna get ice cold. But what's your scale say?
3 pounds, 4.8 ounces.
Yeah. So you got a while to go. Another 4 pounds worth of this. You can keep doing it. You're dropping. So yeah, that should be open. That one's open. That's closed, and then you're just metering based off the charging hose.
How high should that suction pressure get to?
I'm not exactly sure. Everything's really cold right now.
Okay.
The compressor needs to heat up. You're at 4 pounds. Another 3 pounds to go. You're on the right track. So keep it up. You can go a little bit more than that. Let it shoot up to 75, and then close it down. But
Yeah.
your refrigerant's gonna boil off long before it gets to the compressor. As long as we don't slug the compressor, that's the only thing that really matters.
So too much liquid. It's boiling off, like you said, so.
Yeah, just wait until that gets clear, and then open it up again. Because if there's no liquid there, there's not gonna be any liquid here. You're at 5.4, 5.3. So I know I said to add a little bit of extra, but since you have this extra hose, when we get to that point, what we'll do is when you get to 7 pounds, we'll just cut it off right here at the charging hose, and then whatever is the extra in this hose would probably be like 2 or 3 ounces. We'll let that be our
Extra.
Our add a little bit of extra, because we're gonna lose a little bit of refrigerant when we take our hoses off.
Okay.
At 6 pounds, 6.5, 6.6, 6.7. Let it boil off. 5 ounces to go, 4 ounces to go, 3 ounces to go, 1 ounce to go. All right, you're at 7 exactly. So just keep that closed for now.
Okay.
Close it off here. And so you're technically at 7.1, but it just changed 7.2, but moving this will change your weight. So don't worry about that.
Okay.
What I would do is I would like to know what the high side pressure is. But the high side pressure is going to be the same as that pressure. Doesn't really matter all that much, to be totally honest. We can see what the suction side pressure is, and we can tell based off the temperatures whether the high side is doing what it's supposed to be doing. We're just going to let it sit for right now.
Okay.
Then we can keep an eye on our pressure, especially for when we cycle into harvest. We can see what it jumped up to. I always put on gloves when I do that because I don't like getting sprayed with refrigerant, but it's your skin. Going all right? Going all right?
Yeah. Just putting the little grommets back on.
Put that back the way it goes.
Doing a...
This is fully out, so that's closed off. Well, we capped these both and tightened them. Zip tied our filter dryer. Put the insulation back on our TXB. We also, like we checked our weld. This was moved out of our way. Put that back. This thing already made 1 cycle of ice. We're gonna let it run another cycle. Solenoid's back in place. High pressure cutout switch is back to being wired. Everything's good to go. We're just gonna check 1 more cycle, get the times locked down, and then we'll be out of here. So we just cycled into harvest. My freeze time was about 10 minutes. A nice sheet of ice forming. T3 is up to 45 degrees already, which is pretty good. Our hot gas valve is making a good sound, hissing. We got heat on both sides of that hot gas valve. If I put my hand down here, feel that line, pretty warm. And there's my sheet of ice. Should break free and slide forward. There it is, sliding forward. And fell. And let me stop my timer. It looked like a good sheet. 1 minute and 17 seconds for harvest. That's pretty good. So congratulations, Pat. You completed your first, are you really eating that?
I heard. That's confident.
You completed your first hot gas valve change out on this Manitowoc Indigo NXT ice machine. Model number IYF0600N, and still eating the ice.